Hi, myself Dr. J. Glory, Associate Professor of Physics, Institute of Aeronautical Engineering. Today, I wish to tell about the fabrication of nanomaterials. In that, I'm going to tell about the precipitation method. So, before going to that, what are nanomaterials? Already we have discussed that the nanomaterials, that is nanoscale and nanomaterials, and what are the processes, everything. Here, what are nanomaterials? Nanomaterials are usually considered to be materials with at least one external dimension less than 100 nanometers. So, and as we are going to talk about the what is precipitator, what is precipitator. So, we are discussing about the precipitation method. Before that, what is precipitator? A precipitate is a substance. So, a precipitate is a substance that is deposited in solid form. That is deposited in solid form from a solution. So, if we take a solution, so if we keep on adding solute in the solvent, what happens after some time, that is some amount of the solute have been added to the solvent, it couldn't dissolve. The solute couldn't dissolve in the solvent. So, the remaining solute will be left in the solvent as at the bottom of the solvent. So, leftover substance, which is a solute in the solvent, is called the precipitate. So, a precipitate is a substance that is deposited in solid form from a solution. So, as we know that a solute and solvent, if we take sodium chloride, it is a solute. It is a solute. Sodium chloride is a solute, and if we take a water is a solvent. So, sodium chloride can be added to water. So, this sodium chloride can be dissolved in the water. Sodium chloride can be dissolved in the water. So, when we keep on adding this sodium chloride into water, that is which is a solvent, so when keep on adding the sodium chloride solute into the solvent, which is a water, after some amount of sodium chloride, the sodium chloride couldn't dissolve in the water. So that would be left over at the bottom of the solvent. So that remaining substance, that substance is called the precipitator. So a precipitate is a substance that is deposited in solid form from a solution. And what is the precipitate process? What is the precipitate process? So, this method relies on the precipitation of nanometer sized particles within a continuous fluid solvent. So, let's go into that. Nanoparticles can be generated using bottom-up technique in liquids by means of precipitation. So, in this case, a supersaturated mixture starts forming solid particles out of a highly concentrated material that will grow and finally precipitate. So, supersaturated mixture starts from solid particles out of highly concentrated material that will grow and finally precipitate. That is supersaturated mixture. So, when the solute is added to the solvent, when the solvent is highly concentrated, so the remaining amount of solute will be there in the solvent there itself. So, it would be in the supersaturated state. So, a supersaturated mixture starts forming solid particles out of highly concentrated material that will grow, and finally we get the precipitator. In order to control the particle and particle size, that is crystal size and morphology, we should have control over the precipitation influence factors is essential. So, precipitation is the process of separation. Precipitation is the process of separation of insoluble solid from the soil solution due to a chemical change. So there are three types of precipitations that can take place in the soil system. So later we can see the three types of precipitations. So one is precipitation of an element due to supersaturation of that element in the soil solution. Precipitation of an element due to supersaturation of that element in the soil solution. Second one is surface precipitation, and third one is co-precipitation of elements. Co-precipitation of elements. So these chemical reactions can potentially control the mobility and toxicity of trace metals into soil system. So chemical precipitation. Coming to the chemical precipitation, it is the most common technology. So that is chemical precipitation. So chemical precipitation is the most common technology used in removing dissolved metals from solutions, such as process wastewaters containing toxic metals. So in the wastewaters where there is a toxic metals are there, to remove that one, so we use this chemical precipitation. So it is most commonly used technology to remove the metals from the solutions, mainly in wastewater system, purifying in wastewater system. The ionic metals are converted. The ionic metals are converted to an insoluble form by the chemical reaction between the soluble metal compounds and then precipitating reagent. So here ionic metals are converted to an insoluble form, that is particle form, by the chemical reaction between soluble metal compounds and then precipitating reagent. So what is the principle of the precipitation? So the principle of precipitation. So the principle of this precipitation technique is getting the precipitation of our desired materials after reactions occurred by mixing solutes and solvents. So here this technique is getting the precipitation of our desired material. So finally we are getting a desired material through in the form of precipitation. So this desired material can be obtained through some chemical reactions. So when these chemical reactions will be occurred, so when mixing of the solute and solvent, then after mixing the solute and solvent, some chemical reactions has been happen in that solution, so that after the chemical reaction, the desired metal will be at the bottom, which is not dissolved in the liquid, which is not dissolved in the solvent. So like that, a precipitate we can get through this technique. So the principle of this technique is getting the precipitation. We are getting the precipitation as our desired material, after reaction occurs by mixing solute and solvent. So first we are mixing the solute and solvent. So after mixing this solute and solvent, so some chemical reaction happens in the solution. So then the materials which are after chemical reaction, the materials which are not dissolved be left at the bottom. So we get the precipitate at the bottom. So this is a suppose like water. So we are adding some solute. This is a solvent. So solute is adding into the solvent so that it becomes solution. So here this solution contains, when the solute added to the solvent, here chemical reactions takes place. Chemical reactions takes place. So after the chemical reaction, some metals or materials will be left at the bottom, which is not dissolved in the solvent. So this is the precipitate. So this is not dissolved. It is not dissolved. So this precipitate of our desired material can be obtained through this. Okay, so precipitation of our desired material can be obtained after the chemical reactions between solute and solvent. So in this case, the precipitation of ions may occur slowly. In this precipitation of ions may occur slowly. By washing with some suitable reagents or drying up the precipitation, we can get required nanomaterials. We can get required nanomaterials. So after getting this precipitation, we are going to wash with suitable reagents, or else we should dry up this precipitation. Then we'll get required nanomaterials. So this method is widely used to synthesize metal oxides, and insulators with broad band gap along with suitable surface. So this is the figure which gives the information about the precipitation method. So here we have a container. So in this container we have some solvent. That is continuous phase, which is aqueous, and we are pouring some solute. We are pouring some drugs plus oil in organic solvents, so that when stirring with the magnetic stirrer bar, when keeping or putting the magnetic pellet into the container and keeping on the magnetic stirrer, so the pellet will be rotated so that the solution will be mixed up finely. So it can be mixed very well. So that when it is mixed, some chemical reaction has been takes place in this solution. So that after that we will get solvent diffusion and then polymer precipitations. So polymer precipitation. So after mixing up the solution, so we should keep this for some time. So after that, the leftover, after that chemical reaction, that desired material will be at the bottom. It will be at the bottom. After that, we shall collect the precipitate. We shall collect the precipitate and wash it or dry it. Then we will have the required nanomaterials. So, for example, synthesis of copper oxide nanoparticles, we should take some quantity of copper sulfate, and mix with the hydroxyl ammonium chloride. Mix with hydroxyl ammonium chloride in the distilled water. So then the mixture is allowed to cool in a cold water bath with constant swirling. Later, a solution which contains sodium hydroxide in the distilled water added to the mixture. Then the precipitation will be settled down. And the supernatant liquid is poured off. So the precipitation is washed several times with the distilled water until it is chloride free. So then it is allowed to dry at the temperature 200 to 250 degrees centigrade when the precipitation is heated to 300 degree centigrade. So we are taking some copper sulfate and hydroxyl ammonium chloride in the distilled water. So we'll take so we are talking about the synthesizing of copper oxide nanoparticles. So for that we are taking copper sulfate with hydroxyl ammonium chloride in this distilled water. In this distilled water. So then we are making this into cool. And so we are allowing this mixture to cool down in a cold water bath with constant swirling. So later, which contains sodium hydroxide. Later, a solution which contains sodium hydroxide in the distilled water added to the mixture. So again we are going to add some sodium hydroxide. So after this we'll get a sodium hydroxide. And we are again adding the distilled water. So later a solution which contains sodium hydroxide is added in the distilled water. So then precipitation will be settled down. So after that, so here precipitation, precipitate will be settled at the bottom, and above that we have a clear liquid, that is supernatant. supernatant. So this supernatant liquid is poured off and will collect this precipitate. Will collect this precipitate. So after collecting this precipitate, it is washed several times with the distilled water until it gets chloride free. So after getting the chloride free precipitation, so let it be dry at 200 to 250 degrees centigrade. Then it will be heated up to 300 degrees centigrade. So then we get the desired nanomaterial. So precipitation reaction. Let's see precipitation reaction. A precipitate is a solid whose dimensions can be on a micro or nano scale that forms out of solution. So for example, a common mixing of two clear solutions. A common mixing of two clear solutions like silver nitrate and then sodium chloride. Silver nitrate and sodium chloride. So we are taking two clear solutions and mix up well. So the precipitation forms because the solid silver chloride, is insoluble in water. So after mixing up this AgNO3 plus NaCl, so after the chemical reaction, we'll get AgCl. So this is silver chloride. This silver chloride couldn't be dissolved in the water. So this silver chloride does not dissolve in water. So it is insoluble. So likewise, all the precipitate and these precipitations are insoluble in aqueous solution. So this silver chloride will be settled down at the bottom of the solution. So this is the diagram. So we can see the precipitation reaction. So taking a sodium chloride and mixing with AgNO3 silver nitrate. So these two mixed up and we'll get after that, that is after the chemical reaction, we'll get AgCl silver nitrate. This is sodium chloride and this is silver nitrate. So after when mixing these two solutions, clear solutions, some chemical reactions takes place. After the chemical reaction, it gives silver chloride and sodium nitrate. So after mixing up, we are getting this silver chloride. This silver chloride does not mixed in the or dissolved in the water. So the same thing which we are seeing here. So Ag plus ions are there, Cl minus. So AgCl is there. So here in this container, we are taking sodium chloride. So in this sodium chloride solution, we are adding some AgNO3, that is silver nitrate. So in the solution of sodium chloride, adding the solution of silver nitrate. So here some chemical reactions. After that, we are getting AgCl, that is silver nitrate. So, silver chloride. So, silver chloride precipitate can be seen at the bottom of the solution. So, the clear solution, here above we have sodium nitrate. So, this sodium nitrate is a supernatant. So, this supernatant is poured off and we collect this one. Collect the precipitate, then wash with the distilled water. And wash it with distilled water until it is chloride free. So, until it is chloride free. So, after washing, so let the precipitate be dry. Dry the precipitate. Then dry the precipitate at the temperatures 200 to 250 degrees centigrade. Then heat at the temperature 300 degrees centigrade. We'll get a powder. So, which is a nano material, desired nano material. Desired nano material. So, in general case, if we want to understand clearly, so another example we can discuss. So, it is related to a kidney stone. So, a kidney stone is nothing more than a precipitate. So, it is also, we can take as an example, kidney stone can also take an example for the precipitation process. So, a kidney stone is nothing more than a precipitate, often of calcium ions from cheese and oxides. So, it is often suggested that a good way to avoid kidney stones is to drink water, lot of water. So, taking lot of water, it helps because the solubility of the precipitate increases. The solubility of the precipitate increases with amount of water. So, as we are drinking more water, so the precipitate, what are the leftover and dissolved. So, that can be dissolved by drinking more water. So that drinking of more water, the solubility of the precipitate increases with amount of water. So that we can avoid the formation of kidney stones to begin with. So, the advantages of this precipitation method. So, this method is relatively simple and widely used for the production of single and multi-component oxide nanopowders. It is easy to control the particle size. There is a good control on composition of nanoparticles in this precipitation method. Here are various possibilities to modify the particle surface, and homogeneity technology. And coming to the applications of a precipitation method, among all the methods of developing nanoparticles, this chemical precipitation method is good to develop the nanocatalysts, since it allows the complete precipitation of the metal ions. Also, nanoparticles of higher surface area are commonly prepared by this method. In actual use, chemical precipitation can be used as a pre-treatment technology for industrial wastewater. Pre-treatment technology for industrial wastewater and combined with other water treatment methods. It can further reduce the concentration of toxic metal ions. So the references related to this topic: Engineering Physics by K. Tyagarajan, Microbial Education Private Limited, New Delhi, a textbook of Engineering Physics, and PG Kshesagar, H. Chand and Company, New Delhi. Engineering Physics by Dr. N. R. Mudar, Anuradha Publications, Chennai 6/17. Engineering Physics by P. K. Palanisamy, 4th edition, Scientific Publications, Private Limited, Chennai 6/17. And then Engineering Physics by Dr. K. Vijay Kumar, S. Chand and Company, Private Limited, New Delhi. So these are the references which is related to this topic, fabrication of nanomaterials, specifically for the precipitation method, synthesis of precipitation method. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.